Hello and welcome to this edition of Tools for the Craft. We are navigating the Kubernetes ecosystem, and in today's edition, we are going to take a deep dive into a tool that we are developing in our team. It's called Getdeck. As always, it's Robert and Michael. Hello, Robert.
Hi, Michael.
But before we start diving into it, let's just tell me a bit, what have you been up to in your recent cloud native weeks?
Most recently, I'm working on the Getdeck tests. So this is something we will talk about some features and enhancing those tests. And we switched to PyTest Kubernetes, a package with which we can run those tests and spin up a whatever you need, a Minikube or a K3s, and run some tests in Kubernetes in the Kubernetes infrastructure there, which is really nice and really helpful. And it has been quite a while since we last spoke. In the meantime, quite some stuff happened. For example, the meetup, I don't know, it was 4 or 5 weeks ago.
Yeah.
Meetup talk happened, which was a really nice experience. We teased that in the last edition, I think. And that was really nice to meet the community and see that the solution, or that actually the people are interested in such a solution and can really see their use cases. And it's not just a tool we're building for ourselves.
Yeah, and I was especially overwhelmed by the feedback that you got. I mean, there were lots of questions and people thinking how they could use Getdeck for their use cases, put it in their context, and yeah, was quite happy about that.
Oh yeah, that was nice. Absolutely, an engaging audience. They were interested and were thinking about how could Getdeck help them, and also great questions. Yeah, it was really a fun experience.
Wonderful. And I think there is another presentation about Getdeck just ahead. Not quite
Oh
around the
yeah,
corner, but at least in 1 or 2 months, I think.
oh,
It's
yeah,
the
mid
KZD Munich.
July. Yeah. The Kubernetes Community Days in Munich, where I will too talk about Getdeck, and I'm absolutely looking forward to this. So it's great that we are part of
Hmm.
the organization of the KCD, and to have the opportunity to give a talk there. Unfortunately, I've missed it last year, and so I'm absolutely looking forward to that.
Yeah, so fingers crossed that everything's went well. Or will be good for you, because I've heard that we will double our amount of attendees. I think last year we had about 200 people visiting the Kubernetes community days here in Munich, and this year I think it's about 400. 400
Oh wow!
participants and 400 tickets. I think there are quite a few tickets open. So left to be solved, but well, that's at least one of the goals to make a meetup, or better yet a conference. It's spanning 2 days, this big. So I'm looking forward to it, although I won't be able to attend it myself, but nevertheless, will be a blast.
Yeah, I hope
Cool.
so. I
So
hope
then,
so.
well, then let's just jump right into the topic. What is Getdeck? Maybe you can give us a little overview and an introduction about the project itself and our goals, and what are we trying to achieve with Getdeck.
Oh yeah, so I try to keep it short. So basically, we want to achieve ephemeral cloud-based Kubernetes clusters. So a cluster you possibly only have for a limited time, or maybe even for a short amount of time. You might want to run it in a cloud infrastructure, not on your local laptop, on your local machine, because in our experience, well, of course, you have different setups. Somebody's using a Mac, somebody's using a Linux. Stuff works a little bit different, or we see a completely different efficiency. For one, it absolutely works. I can run multiple clusters, and the other can't even spin a one local development setup. And so you want to run your development setup in the cloud, and the ephemeral part, a short-lived cluster, because oftentimes you're only interested in your cluster for a short amount of time. So maybe you work on a feature for a couple of days. You have a dependency you wait for a week, and during that week you don't need to have to run this cluster. Or also, I don't know, maybe for QA testing, or for a short-lived staging system where you can communicate, well, now we have this feature in the staging system and you've got 1 week to test this and give me some feedback on that. And after that, the cluster will be removed because, of course, running a cluster in the cloud can be quite expensive. So this is maybe a really boiled down explanation of what we try to achieve with Getdeck, and of course make it as easy as possible for a developer to spin up clusters and work with them.
Yeah, I think we started with the motivation to provide a development environment, a short-term Kubernetes cluster for development purposes. But as I've been talking to different kind of people from teams and companies, what came up quite frequently in the past, I think, is the expensive sprawl of Kubernetes clusters running in the cloud, running all the time, 24/7 for like all kinds of pre-production purposes. Of course, like a staging and testing system. Then there is a shared Kubernetes cluster for development. Then there are, I mean, you name it, anything that you can imagine. And well, running those clusters all the time becomes very, very, it's not cheap, isn't it? And with a so-called virtualized Kubernetes cluster that runs on top of, let's say, one physical host cluster, we will be able to, limit the costs, being bound to running different environments for a long time. And maybe you know it from your own experience. If you do have a staging system, we do actually run quite a couple of staging systems across all of our projects. And how often do you actually interact with it? How often does a department interact with it, trying those new features, rolling out new features? Is it really that often, or does it maybe just happen 1 or twice a week? And maybe there is a better solution than running a full-blown host Kubernetes cluster all the time. Instead, spin up a ephemeral virtualized cluster, running your branch or your newly added feature, and then expose it to the people checking out the feature and putting their check mark on it, and then just tear it down again in order to save the money. So with virtualized clusters, we will be able, at least in the future, to prevent a bit this expensive sprawl of pre-production Kubernetes clusters. And this is probably something that we will find in our roadmap in the next months to support more use cases. I think at the moment we are supporting a maximum lifetime for virtual clusters. So that is, if you spin up a cluster, you can define how long it will live in total. So limit its a lifetime, and then it automatically is removed once this time is over. And then there's another mechanism. It's a client timeout, or a maximum session timeout, I think, which allows us to limit the lifetime of a cluster based on the connection that is held to it from a developer, for example. And those are very important features to make this cost-sensitive provisioning of different environments, different stages, to put a handle on it and better control what is really needed and what might only need it for a certain amount of time.
Oh yeah, that's absolutely a good point. And of course, me personally, I'm always more interested in what can I do with this? How can I profit as a developer? But of course, the business case is super valid. I mean, if you have to make that decision in your company, no matter how big that company is, you will probably be impressed when hearing, right, you can save some money by this and you can spin something up. And if you don't need it, you can shut it down, because of course, this always depends on the project, or maybe which phase of the development of that project are you in. But if the project is running robust, do you actually need a continuous staging system, or is it more like, well, every 2 weeks you need it for a couple of days? The customer can check out some features, can approve them, can give feedback. Of course, it's convenient to have it available all of the time, but well, does it need to be running all of those 14 days, or might 2 days actually suffice? And currently, this
Depends
is,
how deep your pockets are.
yeah, absolutely. And currently, if I think about it, maybe it's not super efficient if we, of course, and I as a DevOps could sit there and be like, yeah, well, I'm removing that cluster, and in 10 days, going to spin up a new cluster and deploy all workloads in there. But this would also be quite some hours of working time, probably. And so it's maybe a little bit debatable if we then actually save money if a person needs to sit there for a couple of hours, for 3-4 hours, to spin it up and afterwards delete it again. So of course it's much more convenient to just spin up an ephemeral cluster. And you also made a good point, which I want to emphasize. We are basically talking also about virtual clusters here. So we have this one host cluster in which we spin up multiple of our Getdeck clusters, which also makes great use of the resources, because you have this one cluster which we try to use optimally. And we don't have the case that every developer needs their own Kubernetes cluster, because nobody is working all the time on all projects. So this should probably also reduce your overall resources.
Yeah. Maybe compared to a development department with developers having like huge machines with a huge amount of resources running their clusters locally, what would you say in terms of the costs coming with it? Will it be cheaper to virtualize those clusters in some kind of an elastic cloud infrastructure, or let's say run it on a local development machine?
Well, in my opinion, overall, you should profit. It should be a little bit cheaper if you run it in a cloud infrastructure. Of course, that is quite expensive per month. And for your developer, you only need maybe one huge machine every couple of years or whatever. But keep in mind that a cloud infrastructure makes access easy. So if one of our developers has some kind of issue and needs my help as a DevOps, I can easily access it via the cloud. And in a fully remote setup, as our company works in, I just can say, well, I'm coming over to your laptop and going to help you real quick. We need to do a screen share, and this is, well, quite tough debugging from time to time. And so I think that with those costs, or you will save some time and also save some money, because you don't see issues of, well, it works on my Linux, why doesn't it work on your Windows or Mac OS? Or, well, I don't know how it works on your Windows or Mac OS. Let's find this out. You have some more homogeneous setups there. And of course, the aspect, I can way more quickly debug some kinds of issues if I have direct access to the cluster.
Yeah. So this is all related to the collaboration and improving the collaboration over those development environments, which probably make a significant impact on how expensive the whole development infrastructure will be. But as you said, it's maybe quite like similar if you buy very expensive development machines versus buying or equipping developers with like average or commodity hardware, compared to like having commodity hardware in place on the developer side, and then providing their development environment, running the actual workload in the cloud, which should be maybe the same. I don't know, never really calculated it. We should make a case. But in the end, if you improve the collaboration, and also the development continuity, I mean, you've been talking about some developer messing up their local environment, and then it's up to you to get to them, maybe using a video call, or in the past you probably went just across the floor to fix the local issues. Then with those virtualized cloud-based development solutions, you have a good approach to fix their problems in their environment, and that's probably way cheaper than it was before, than it is running a distributed world of development environments, basically.
Yeah, that's also absolutely my intuition, but of course I haven't calculated that business case as well. So
Yeah, it's super interesting. All I want to say is there is probably some kind of bare numbers in terms of costs attached to the whole thing. But we are coming from a DevOps side. We are more on the solution to make it more convenient, development, to make it more standardized, to make it more quickly and swift to spin up environments, do the actual work, writing code, and then like changing the context to maybe another service, maybe another feature, or even resetting the whole development infrastructure and starting from a clean baseline,
yeah,
which
that's also a
should be
super
possible with Getdeck.
that's also a super interesting point from the point of view as a developer, because as a developer, I'm not necessarily very much interested in my infrastructure. How does my Kubernetes run, and what do I need to do in order to fix it or to spin it up? No, I quickly want to spin up my cluster, and I'm way more interested in the services I'm going to develop in that cluster, but not in the infrastructure itself. So the time I can save by not working or not having to interact with the Kubernetes cluster for all our developers is I think is a very big plus if you have a solution like Getdeck.
Yeah, I think that makes the motivation clear. Do you see any points speaking against doing it like this, just for the sake of completeness? I mean, of course, you have to maintain at least the host cluster, but in a Kubernetes ruled world, that's probably a well manageable requirement.
Yeah, so you
But
have to maintain
what
some
else?
Kubernetes clusters somewhere. So either you're managing this host cluster, or you have to manage development clusters or staging clusters in the cloud or on local machines. So maybe that's not a huge factor. Well, of course, I'm heavily biased, and I think Getdeck is a really great solution. I don't know why I should do it any different.
Yeah, I mean, to be honest, we have some kind of overhead, of course. At least there's one operator running within the cluster. It takes, although it is very fast to spin up a Getdeck cluster, it takes obviously a few seconds. That's probably comparable to the times that you're seeing on your local machine, but still. And then there are maybe, just maybe, some kind of connection related issues coming with it. Let's say you want to work in a train, or you have a poor internet connection and you have your whole development environment running in the cloud. That's probably some kind of a downside coming with it. But maybe that's not too much of an issue, because most of the developers should be supplied with a very good internet connection anyway. This could be an argument.
Yeah, absolutely. So if you have everything running in the cloud, you are super dependent on the cloud, and if your connection is not that stable, you're gonna have troubles, sure.
Cool. So then, just to sum this up, we have flexibility and scalability that's going to be improved with cloud-based remote clusters. In any case, the improved collaboration is something that is very valuable coming with this approach. The consistency, we are providing consistent development environments across the team. Everyone is working with basically the same setup. And then we talked about the reduced costs that we are hopefully seeing when teams apply Getdeck. But obviously, it's not just the costs coming with the tech and the resources, but the overall, the whole picture. There's just one point missing from my summary here, is the point of increased security. What's the case with this approach and security?
Well, of course, you can more, or you have a fine granular the possibility to kind of determine, or to kind of set who can access which cluster when running this thing in the cloud. So I'm thinking a little bit in that direction, that you can say, well, we have this development team which should only see those resources, and that development team which should only see that resources. They're sharing basically the same host cluster, but running in their own virtual clusters, which they can't mutually access. So I'm kind of looking in that direction.
Okay, so granting access to resources. What about rolling out data to development machines? I mean, if you're providing a cloud-based development environment, you're very much in the control of the data that goes into it. But if you require developers to pull databases or data sets on their local machine in order to work with it, and you are a rather large development team, maybe you have some external developers in your team just as well. So you are deemed to grant them a data set that is close to production, hopefully anonymized, but still. And with a cloud-based development solution, the challenge is still the same, but at least the data should not touch the development environment of your workforce. And this could increase the security just as well.
Oh yeah, absolutely, absolutely. That's a good point. Yeah.
Okay, so how did we get started with Getdeck? And what other solutions are potentially out there already?
Well, we might look at the history of Getdeck, where we kind of envisioned we want to have a deck as some kind of let's call it a container of Kubernetes resources, where I'm saying, well, this is my service and it's running in those kind of dependencies. And we thought it would be good if you could just say, well, just do deck install and everything I need will be installed. And over time, we kind of got on track on realizing, well, a cloud-based ephemeral cluster would really be a nice thing. And also, if I can store my state of that cluster, I can throw away that cluster and can restore that state, or I can even share that state. So the kind of advantages we talked about. So this is a little bit of the history of Getdeck, where we started out from. And to be honest, on the or when doing some research, I don't see that many different products which the same kind of goal of those ephemeral cloud-based clusters or virtual cloud-based clusters. And the main thing you're going to find is, of course, vCluster and some other solutions, but most of those seem to be, let's just say, not active anymore. There are some which had their last commits a couple of years back or 3 years back, so they seem well, highly inactive. And so basically, I'm only aware of vCluster. Do you know any other solutions or maybe some up-and-coming solutions?
I think there was a Kubernetes zig running a project which was quite similar, but I found it to be quite inactive just as well. So not really. I only know vCluster. I mean, you can't get around vCluster. vCluster is some kind of a market maker in this sphere. But well, we wanted to start with our own solution, obviously, and coming from the concepts of having a deck file that describes not just a service, like using, for example, Helm files or something like that, but instead providing the whole cluster with the ingress controller, with the Kubernetes dashboard, for example, with services being provisioned with Helm, services being provisioned with Customize or plain YAML documents. And that was basically the deck file. And from that idea, we shifted the whole thing into not just provisioning local Kubernetes clusters, that is what the Getdeck CLI is still doing at the moment, but rather provisioning cloud-based virtualized clusters. And then we found vCluster. And I think one thing that we haven't been very happy with was the fact that vCluster is running some kind of a syncer component that is syncing the workloads from the virtual cluster, so basically the pods, into the host cluster, and providing a, well, speaking about isolation, right? There's some maybe a bit fewer layer of isolation between the host cluster and the virtual cluster. And with Getdeck, we are running everything within one pod, looking from the host cluster, and which allows us some other nice features that we may support now or in the future. And but basically vCluster is much older, much more mature, and it probably serves quite a good amount of what we are trying to achieve in the future. Today already. But we'll see, because we want to control the stack and to be able to influence the direction of the project itself. And I think when we're talking about the other components coming with the Getdeck project, this might get a bit more clear why we decided to start our own.
Yeah, one thing also, I think vCluster has a strong emphasis on multi-tenant Kubernetes, or is that just my impression? So maybe I think that example is from them, that you can run your one Kubernetes cluster and run Pepsi and Coca-Cola alongside each other, and they don't really interfere.
No,
and I think
this sounds like an example that
you made. Yeah, maybe.
Yeah.
Maybe it's also an example
But
from
it's
you,
fine.
but I think they have this quite huge emphasis on, well, you can achieve multi-tenant Kubernetes, which maybe isn't something that we really specialize on with Getdeck, or that wasn't in our initial motivation. I think our largest motivation starting out was, well, I want to quickly and easily achieve a Kubernetes dev setup where our developer can work with. And I think we are very much motivated from that aspect in trying to, well, how can this thing run really quickly? How can this, how do I achieve a very quick setup time as a developer? And even if I don't know that much about Kubernetes, How can I easily store my state and restore it and share it so that I have a lot of developer convenience there.
Okay. Cool. So before we get started into a demonstration from your side, do you have some like practical experiences for us? I mean, we're running a virtualized cluster in the cloud, and we are selling it as a development environment. How does the actual development work then being? How's that done on my from my local machine? How can I write code and see it in this virtual cluster, or test it with the cluster, or reach resources in the cluster? How's that done?
Well, maybe two aspects. Getdeck directly won't help you with developing inside that cluster. So Getdeck is going to provide this cluster for you. You can connect with that cluster. It's going to provide you with a kube config. And you can use that to interact with your cluster, and it just feels like any other Kubernetes cluster. So as a developer, it doesn't really make any difference for me in how I develop, if that is running a cluster on my local machine, if it's a cluster running in Google or in AWS or whatever, or if it's a Getdeck cluster. And
So
if we want to talk about, yeah.
It's much comparable to, let's say, K3D or Minikube or kind like local Kubernetes providers, tools that allow me to, or even Docker Desktop that comes with a Kubernetes built-in. So Getdeck itself is much comparable to this kind of tools, right?
Oh yeah, I would say so. And as I've said, as a developer, I don't necessarily see any difference or experience any difference in my day-to-day work. Of course, if you dive a little bit deeper, if you really get into the infrastructure for whatever reasons, you're gonna see some differences there. But I think for the majority of development work, you won't see any difference there. So it's just any old Kubernetes.
Okay. And the second aspect?
Yeah, well, the other aspect I'm thinking about is if we want to talk about the developer's convenience in developing Kubernetes applications, you probably want to use some other tools in combination with Getdeck. Getdeck is just a Kubernetes provider. And you want to think about how can I actually run my code kind of in Kubernetes without the build, push, pull cycle. I don't want to build my local code, then my super minimal bug fix or whatever. If I have to build that and push it and wait some minutes until that's done, and then I can deploy it and check it out, this is a super shitty experience.
Just to see it break the system again.
Yeah. So this is super frustrating if you have to wait a couple of minutes or even just 1 minute if you only have some minor changes. And you might want to use some other tools there.
Can you name a few?
Well, of course, I would name Gfira because that's what I'm using and what we also develop, which more or less links a local container in your cluster. So you have a local Docker container that is kind of linked in the cluster, and you have your code available instantly there, which is super nice. And mostly our projects, or the projects I'm working on, are built with the Django framework in Python, which has this hot reloading feature available. And so I can just develop, and it's more or less like I'm developing on a local Django run server, which is absolutely a great experience. And of course, there are other tools. There is Telepresence, which kind of achieves the same, which we weren't that happy about, prompting us to start development of Gfira. And in the direction of improving the build push update cycle, there are, of course, tools like Tilt and Devspaces and Skaffold, which I don't really have that much or any experience at all. And of course, you can work with no tool at all, but that's probably the case we already talked about. going to use kube control, edit and apply, or do some rollout restores, or delete some pods. Which you don't want to do.
That's. I mean, maybe this is doable for very experienced developers that have seen like infrastructure and Docker containers or containers in general, and then the whole Kubernetes ecosystem. But it's probably not feasible for many developers, as they are, of course, focusing on writing code instead of managing infrastructure. That leads us back to the dev versus DevOps versus ops question that we have been talking about, I think, in almost every edition of Tools for the Craft, and haven't found a solution by now. But we should spend a dedicated edition on just this topic.
Absolutely, it's kind of coming up in every edition and here and there, but we don't really take time to figure it out. So it probably deserves its own edition.
Yeah. Okay. So now I'm keen to see it in action. You prepared a little demonstration, hopefully.
Yes, I did. So let me just share my terminal.
Surprise.
Gonna share this. And so here is my terminal. I am connected to our Kubernetes host cluster where Getdeck is already installed. And you're going to see the phrase byboat a lot, which kind of was our name for this ephemeral cloud-based aspect of Getdeck, which we decided to kind of rename it or reframe it and get back to just the Getdeck. So there is a lot of stuff that's going to be named byboat, just so that you or our listeners know what's what.
I think we will stick with the name for the component itself, the operator providing virtual clusters. But there are, of course, quite a few other components in the whole chain as we work our way through. It's Getdeck.
Yeah. And so we might want to take a look into the cluster and just see what kind of pods we've got running there. We got quite a lot. It's kind of this a little bit of a mixed cluster for us. So we see some Gfira components. But if we look at the Getdeck namespace, we see we got our operator running in there. We got an API running in there, which we might talk about a little bit later. And some other deployments. And we also see we have one cluster running here. Might have cleaned that up before. We can clean it up. And of course, we got some bunch of other components in the kube system namespace. Here we see some rook ceph, which we use to enable our storage situation there. So we are running this cluster on Hetzner, and we need rook ceph to provide the volume snapshot API. So to support the volume snapshot API. So there's that. That is our cluster, and the tool I'm gonna be using is the byboat CTL, which we can just check out by running byboat CTL --help. We see some commands here. We have a cluster command to manage our byboat clusters, so meaning creating and deleting and listing byboat clusters. We have our connect command. If we have a byboat cluster running, we can connect to that cluster. As I've mentioned before, if we connect, we are going to be provided our kube config, which we can use to interact with that cluster. Afterwards, we can run the disconnect command. We can run the install command to create and print the Kubernetes configs for byboat. So if we want to freshly install byboat in a new host cluster, we're going to run the install command and apply those resources. We have the shelf command, which is our name for storing and restoring the cluster states. So if I have my development set up, which might take some time to set this up and to provide the data in there, I can just run this shelf command. I can delete my cluster and restore the shelf later. And of course, we have an uninstall and a version command. So what we might want to do first, just out of curiosity, is to run the install command, which will just print the Kubernetes configs. And if you run that, we see we got a bunch of Kubernetes resources here. So the last thing we see here is our deployment. It's the bytecode operator. We have some config maps and quite some stuff, validating webhook configurations and all the stuff that's needed. So maybe we're talking about a dozen Kubernetes resources here, which is conveniently printed out and of course can just be run with kubectl apply, and then we have bytecode running in our cluster. We don't need to apply those resources. As I've mentioned, bytecode is already running, so we can just check out our clusters. If I run bytecode CTL cluster list, yes?
Just on a word about bytecode CTL, this tool is targeting not developers, right? It's not intended to be used by developers. It's more kind of a management utility, isn't it?
Yeah, absolutely. It's kind of more the on the management side, for those people who have to manage the cluster, or maybe also for those kind of developers or DevOps people who just prefer a CLI tool. Maybe there are those. We are also working on a desktop app, which of course makes it super convenient, and which probably will be used by most developers, where you can just click around and have it available more conveniently. Because of course with this CLI tool you kind of have to figure out what do you need to do, what are the flags. You have to know that stuff, or you have to find it out, and then you're going to store your little scripts or whatever. And that's not really convenient for every developer. So the desktop app should solve that problem for most developers.
Yeah.
So yeah, let's just run our bytecode CTL cluster list, and we see we have a cluster already here, which is from my test before our podcast. We can just delete that one because we don't need it. So we run a cluster delete. We see that it is marked for deletion if we list it, and it's already gone. So we are interacting with the operator here. If most of the bytecode CTL commands are going to create a custom resource definition or prompt the deletion of that custom resource definition, our operator, which is implemented with the COP framework, is going to pick up this custom resource definition or any changes in there, and is figuring out, is there something to do here? Do I need to create a cluster, or do I need to reconcile it, or should I delete it? Or is this thing in kind of an erroneous state? Is it not anymore in an erroneous state? Is it running? Is it ready again? And so this is our way to kind of interact with the operator here. And so we have a clean slate now. We don't have any clusters running, so we can just create our cluster. I'm gonna name this cluster spacecrafts. I'm gonna provide 2 flags. I wanna run 3 nodes, and I'm gonna expose the port 8080 to port 80 here. Although I'm not sure if we're going to show this in the demo, because it would mean that I'm going to have to switch what I'm sharing here. But of course, if you're exposing ports from inside the cluster to your local machine, you can, for example, access your website that you're developing on directly in your browser, which of course is a super necessary thing as a developer. And meanwhile, we have seen
I think this is very important. I think this is very important when I talk about developers having the feeling that the virtual cluster runs on their local machine, as we indeed bind ports on the local machine that are then being accessed by the web browser or any other tool that runs on my machine. And this is then being forwarded into the cluster. And with the ports flag, we are creating a port mapping. It's obviously that you can use this option multiple times in order to bind a certain amount of ports. But yeah, this is, I think it's a very important utility for making the developer experience better.
Oh yes, absolutely. So speaking from my experience as a developer with this tool, this really doesn't feel like I'm interfacing some kind of cloud cluster, or it reduces any kind of interfaces between me and this cloud cluster. So it feels like it's running directly here where I am right now. And this absolutely is a great thing. And of course, speaking of great things, what we see here, our Bible cluster became ready in 21.5 seconds, which is super quick for a Kubernetes cluster. Sure, we have our Kubernetes host cluster already running, and we quote unquote only have to deploy our resources there, our virtualized K3S Kubernetes cluster, but I have this up and running in 20 seconds and can work with that. This is really, really a great time, I think.
I could have asked why should I, or why is it not feasible for me to spin up a GKE cluster, for example, or EKS, or a cluster at any hyperscaler, basically. But I think 21 seconds pretty much answers this question already. And it's probably
Yeah,
gone in less than that.
yeah. As we've also seen the deletion, I've checked that the cluster list out a couple of seconds later, and it's already gone. And this is really, really convenient. And as we said, if I'm gonna work with AWS or GKE or EKS or whatever, I would be surprised if you achieve really anything or really much in 20 seconds there. And even if you have all your resources ready and just have to run a CLI command, the cloud provider will take some time until your cluster is finally fully provisioned.
Yeah, which seems intuitive. I mean, they are provisioning physical resources. I mean, those nodes are virtual machines after all, but still they are running a whole control plane for you, and they are bootstrapping a fresh Kubernetes cluster. So how does Getdeck achieve 21 seconds for a fresh Kubernetes cluster?
Well,
How is that even possible?
one thing we of course have to mention here, if we look in our host cluster and check out our nodes, there are some nodes running, and a thing that could happen, of course, is if we request a new cluster. I'm gonna switch to the pods again. We see what's going to be deployed. We have this Bible tunnel, and as I've said, I want to have 3 nodes available. We get a server 0, an agent 1, and agent 2. So we get 3 pods in total, which correspond to our 3 K3S nodes. And if our cluster realizes, well, I don't have any resources for those, another node needs to be provisioned. So we kind of can have luck or we have no luck, and we have to wait until that node is ready, which means, I don't know, depending on the provider of your host cluster, of course. We have a node autoscaler enabled, so we have to wait another minute in a worst case scenario. But if our Bible cluster fits in the host cluster, we just have to, or the operator just have to create those pods and start the K3S command inside of those pods.
Yeah, I think adding a node to a node pool to an existing Kubernetes cluster should be fairly quick on most managed Kubernetes platforms, compared to bootstrapping an entirely new Kubernetes cluster, which at least on the Google Kubernetes engine takes about 20 minutes end to end, if we are fully honest here. And it's even worse with AWS.
Yeah, so now that we have our cluster available in 20 seconds, we can run our cluster list again. We see our cluster and the namespace and the state. It's got also a UID, of course, and maybe we can just see what else do we have available here. We have seen create, we have seen delete, we have seen list. We can run inspect on our cluster. I'm gonna run this really quick. Bible.ctl cluster inspect spacecrafts, which is the name of our cluster. And we see some information, some metadata and the parameters with which the cluster started. We see our port from our port mapping in there. We see another port mapping that we might need for the connect. And we see a max lifetime and a max session timeout. We've talked about that earlier. Both aren't set in this cluster. Those are none. We have 3 nodes running. And we see some other parameters which we could set or change if we need those. And also we see some events that are printed that our cluster experienced. So yeah, now we have our cluster set up. Bible.ctl cluster list. It is still there, of course. Now I'm gonna be running a connect command, which is Bible.ctl connect spacecrafts. Spacecrafts, of course, again being our cluster name. I'm gonna run this. This was also really quick. We see that it created some port forwards for the following ports, which are listed here. The localhost 8080 to cluster 80, which I specified when creating the cluster, and the 6443. We see the kubeconfig file that is written to a path, which is printed out here. And we see also helpful the kube control command, which uses this kubeconfig. So I can just run this command kube control with the kubeconfig of the path that I got and just run get nodes. And we should see that we have our 3 nodes in there. They have been created 8 minutes ago. Our server 0, agent 1, and agent 2, which are all ready. So for me personally,
it reveals that Getdeck is using, and it reveals that Getdeck is running K3s under the hood. A very great project, by the way.
Yeah. So what I'm gonna do is I'm gonna be exporting the kubeconfig in my environment here, so that I don't have to run the command every time. So I can just run kube control get nodes. I am in this cluster now. I can run get pods. I just want to see what kind of pods are available there. We don't have really much running here, just 3 pods, a metric server, a core DNS, and a local path provisioner. And what we can do now is I'm gonna change into a local directory here where I have the spacecrafts demo available. Our spacecrafts demo, we just kind of developed this for a blog post, if I'm not mistaken. It's just a very, very simple Django application with a GraphQL API. We can look at the Git remote. Yeah, you can also find it on GitHub under our Django Hurricane project. I'll be creating a namespace called spacecrafts, and unfortunately we see an error we currently see quite regularly, the unable connect to the server and the file. Currently, we are in a kind of beta phase, so our solution is to just try again until it works, and it usually takes a couple of times. Now it's taking me 4 or 5 times. Okay.
No worries, we cut that out later.
Yeah. Well, we have our suspicions where this might be coming from, but of course we need to work that out until we release the next stable version. So yeah, our namespace has been created, and now I'm just gonna be using Helm to install the spacecraft application in the namespace, spacecrafts. We also see a warning from Helm here that the Kubernetes configuration file is group readable, and this is insecure. Of course, this is also something we should be changing. We see our Helm install should have worked, and so if I'm gonna run the kubectl get pods in the namespace spacecrafts, we should see 2 pods in there, a Postgres and our application pod. And yeah, they are in initializing and container creating. Yeah, they're both running. They are kind of quick. Although I don't think we have really a sophisticated readiness and liveliness probe, the application should wait until the database is up and running and they kind of start. And yeah, after some time, they should become fully ready.
And the app is being served under spacecrafts.dev.localhost.nip.io, isn't it?
Yes, so we should see our ingress. If I run kubectl get ingress in the spacecraft's namespace, we see exactly what you mentioned, the spacecrafts.dev.localhost.nip.io. And with our port forwarding, which I entered when creating the Bybot cluster, I could reach the app in my browser under this domain, of course, with the port 8080 followed. And so I could check out what's running there. I think we are gonna stick to the backend part. I can exec into a pod and create something in the database, so we have a kind of changed state of our application. I'm gonna look if my pods are running now. It seems like it. So I'm running kubectl in the namespace spacecrafts, and I'm gonna exec into the application pod. And also with the kubectl exec, we kind of often see the EOF error, which we now know the solution. Just try again, and it worked. Awesome. I'm now in a bash in the container of the application pod. I can run a Python manage PyShell plus. And I can see we should have something here, which is a component, which is just some model in this application. We can kind of check out the first component. It has a title, for example, which is called here stuff. So this is a great sophisticated model, of course. And we're just gonna create another one, which we call tools for the craft. Oh yeah, and I see we have a failing constraint because I think I need to specify a foreign key relation. I haven't been active in this application for quite some time. What do we have here?
You can also rename the title stuff from the object that you just stored to variable C.
Yeah, that would probably be quicker. I think it's the category that we have to set.
Tools for the spacecraft.
All right, tools for the spacecraft. So, and if we are gonna look at our all components again, we see that stuff isn't in there anymore, but it's now named tools for the spacecraft. Of course, that is a very, very, very basic example of a changed state. Usually you're going to develop some kind of feature, or maybe you work on your API, you provide another endpoint or two. Maybe you have kind of created some kind of test data in there manually or in any other way. And you want to...
Or you altered your database scheme.
Absolutely, yeah, sure. And now we've made our change. Maybe I know that I won't be working on this project today, and tomorrow will be the weekend. So at the earliest, I will be working again on Monday, maybe even Tuesday or Wednesday. And what we can do now is I'm gonna go out of the Shell Plus and gonna go out of the container. I am here now back in my host cluster. I'm gonna get out of K9s and run vClusters cluster ls. We still have our cluster. And what I now want to do is use the shelf command to store the complete state of the cluster. So shelf is not creating a database dump or a media dump that you can later restore, but it is storing the complete cluster itself using the volume snapshots of Kubernetes. Storing those, they are then available in our storage, and later on we can use that shelf to restore the complete state of the cluster again.
Just because I have heard that question quite a few times already, it is not possible to migrate the state, the shelf object, to another cluster, right? We cannot make the shelved cluster available in another host cluster.
No, that's not available. Yeah, it might depend on where your host cluster is actually hosted. So the Kubernetes volume snapshots kind of are a little bit analogous to the persistent volume claims and persistent volume. So you create a persistent volume claim, which creates the persistent volume, which actually gets some space, some storage space of your cluster provider. And the volume snapshot is kind of equivalent to the persistent volume claim. So I'm going to say, well, take this persistent volume claim and store this in a snapshot. And then Kubernetes is communicating with the cluster provider, and it's going to be creating a volume snapshot content. And in this volume snapshot content, a snapshot handle is provided by the cluster provider or by the storage driver. And maybe you know that it's just some string, and maybe you can use that in another cluster if it's running in the same cluster provider and you have actually the access rights to that object. This is something I haven't tried out yet, but currently, of course, also as the way Shelf is currently implemented, this is not supported. So you can just use this on the same host cluster. But maybe under some sort of restrictions, there could be a possibility, but this has to be explored, of course. Currently, it's bound to one host cluster.
Yeah.
So what I first want to run is bybotctl shelf help, so that I can just see the options, the subcommands we can run here, which is also like cluster. We can create, we can delete, we can inspect, and we list. We just want to create. I need to enter the name of the cluster, which is spacecrafts, and I can actually enter a shelf name here, which I'm going to be named TftC, Tools for the Craft. So I just need to enter the name of the cluster. I can optionally specify the shelf name. If I don't do that, a name will be created automatically with the timestamp. And if I run that, we see that the shelf with the choose name is being requested, and I can check the status with biblectl shelf ls, which I will just run. ls is the short form for list, of course. We see we have some other shelves as well, and at the bottom of our list we see the TftC, which already became ready. So this also didn't take a long amount of time. We might, or maybe we do that later if we want to look at the volume snapshot and volume snapshot contents that have been created. Or yeah, I don't know. Would you be interested to see that, to check those out?
I'd rather be interested in the fact if we can create shelves every time that we are doing any change to, or any changes to this cluster, so that I'm like have certain evolutions of my development environment. Let's say we have like what you have shown, just a database and a service, and then now I can install another service to it, and then another service, and then create shelves from it in order to, sorry.
There's something going on in your background.
You got the question?
Yeah, I think so. So of course, we can just always create another shelf and another shelf. So what we might want to do here, we are back in our cluster, and I can just deploy an Ingress Nginx controller in there, which you oftentimes need. Now we have changed the state of our cluster here. Kube control get pods. I'm gonna look at all pods that are now deployed. If you remember, when starting out, we just only got our 3 Kube system pods. Then we installed our 2 spacecraft pods, and now we got another, I don't know, 5 or 6 pods from our Ingress Nginx controller. So we applied some more resources in there. And I can just run again the shelf create, and of course I need to change the name of the shelf. And this now reflects both changes. So if I run biblectl shelf ls, we see both shelves, the TftC and the TftC2.
Now we catch it pending.
Yeah. Now we caught it pending. We were quick enough. Yet now it's ready. So for this cluster, it's quite quick. Of course, there is not that much state in there. If you have a huge database and many media files or whatever, it probably will take a little bit longer because, of course, probably depends on the size of the persistent volume claims that need to be shelved. So kind of the nodes that are running in the Getdeck cluster. If you have a lot of stuff stored in there, it will take a little bit longer. But yeah, it can also be very, very quick. So we have our 2 shelves now available. The first one and the second one with the Ingress controller. And what we can do now is that I just create, or just open up rather, a new terminal. I have a lot of kubeconfig exposures here. We can list our clusters, and what we can do now is that we just create a new cluster from the shelf, or from one of the shelves that we just created. Or maybe just for completeness sake, we can also really quickly run the shelf inspect command on one of our 2 shelves here. We looked at that for the cluster. We have run the cluster inspect before, where we got some metadata and the cluster parameters. Now we have the volume snapshot contents listed, which is basically more or less what is stored inside the Kubernetes volume snapshot content. So we see the actual name of the resource. We see the node which is stored in that volume snapshot content. We see the persistent volume claim of that node. We see the snapshot handle, which has this path here, I know in Google it's just like a regular file system path, and we see the volume snapshot name. Some of those resources are needed if we are going to restore our cluster from that, or probably all of them are needed if we restore that. And yeah, we kind of see this overview of what actually is stored. We see that we have 3 volume snapshot contents, 1 for each node, agent1, agent2, and our server. And of course, also here we have some events, not as many as we have seen with the cluster. But yeah, the shelf only has a couple of things to do. So what we now can do is run our vCtl cluster create again. I'm gonna run this thing, name this thing TftC restore, and I don't need any additional flags like I know this cluster has 3 nodes, so I don't need to specify those. That is actually also stored in the shelf. What I can just do is run the flag -- from shelf, and I'm gonna be restoring from the shelf TftC2, and this should be enough. Yep.
I thought you better restore the TftC to see that the ingress controller is missing.
Yeah, we can restore that as
anyway,
well.
you're still connected to the original cluster, right?
Oh yeah, that is absolutely a good point. I have here my terminal where also the kubeconfig is exported, so I can just run vCtl cluster ls and disconnect from the spacecrafts. I'm now disconnected, so my tunnel to the virtual cluster isn't there anymore. So I should also not be able to see the pods in that cluster. Yeah, of course, the connection was refused. And we see here the creation of the cluster from shelf is taking a little bit longer. Of course, the resources have to be restored. So what's happening under the hood is we have our volume snapshot contents, where our persistent volume claims of the nodes of our server and agent1 and agent2 are stored. And those need to be made into new persistent volume claims. And this is what's taking longer here. So unfortunately, we don't see our 20 seconds for the restore cluster, but we have it available in 80 seconds. So it took about a minute longer, which is still, I think, reasonably quick. If I can restore the complete state of the cluster in 1.5 minutes, I'm quite happy because that's not exactly a huge waiting time.
I think with Getdeck, we only have to beat the time providing a blank Kubernetes cluster, applying resources to it, and then waiting for the workloads to stabilize and for the database to be restored from a backup. And all of that should be taking way longer than 82 seconds to achieve just that.
Oh yeah, absolutely. That is correct. So what we can now do is maybe we want to look into our host cluster and be running K9s again. And we can see now that we have our original cluster that's still running these spacecrafts, and we see we have another cluster which with also 3 nodes, a server and 2 agents in the namespace Getdeck BBT TftC restore. The TftC restore being the name of the cluster that I've chosen. So what we now want to run is vCtl connect TftC - restore, the cluster name. And now let's look at all pods that are running in there. And we see we have our spacecraft pods running in there. Actually, the PostgreSQL is still pending. So our application pod is restarting again. It's not a really sophisticated setup. and we have our ingress resources that we applied there. So we just have to wait a little bit until the application stabilizes itself. Of course, when using an actual application, you probably have more sophisticated liveliness and healthiness probes, so you hopefully won't see a lot of restarts there. Yeah, well, it's taking a little bit. Still pending. Maybe there is actually some issue there.
Well, it's always the case when making a live demonstration.
Yeah, absolutely. So maybe we just describe. Describe this pod. You will seem to have a volume node affinity conflict. So I'm not quite sure what is going in there. If this is a setup where you can be lucky or can be unlucky.
I think you did this demonstration quite a few times already, and it always worked. It's too bad that we're seeing this issue here right now.
Absolutely, I'm also a little bit surprised, but yeah, well, this Postgres, of course, is having its own persistent volume claim and the persistent volume, and maybe there can actually be the case where there is a volume node affinity conflict, which you might be able to resolve in your resources, which is not the case in this demo setup. Nobody really expanded a super huge amount of effort in there. So I'm a little bit disappointed that this didn't work here. But yeah, well, maybe we should try to restore the other shelf.
Yeah, version TftC without the ingress controller.
Restore one from shelf TftC. So let's just restore that and see if we are lucky.
Okay, so you're now you're still connected to the other cluster.
Oh yeah, I am.
And that's what we've been talking before about collaboration and making clusters easily available to others. So that's basically it. You connect to a cluster, and then you got the ports forwarded and the API server just as well, and the kube config, and you are able to interact with the cluster. And that works for your peers just as well. If you want to let them work with your clusters, or if they ask you to look into their issues, you're able to connect to their virtual clusters and then.
Oh yeah, absolutely. So it's as easy as that. So if you are somebody who works with the Bible CTL, you can just hit that command if you have access to the cluster, of course. And then you should be up and running and check out that cluster. So if maybe a developer is restoring that shelf and is hitting this issue, and of course you need to look a little bit deeper. What does it actually need, this volume node affinity conflict, and how can we solve that? Maybe not every developer works that much with Kubernetes to be able to solve that or solve that in a reasonable time. And so that might be a prime case where somebody asks me, hey, can you help me with this? Can you check this out? And so I can, on my own, connect with the cluster and kind of solve that issue, work that out. So what we have seen here now is that our cluster became ready in 52 seconds. So it was a little bit quicker.
The Ingress controller is eating up the rest of the time.
Maybe. If I will CTL disconnect from our TftC restore. And now I can connect to the TftC restore 1. I'm gonna take the path to the kube config and I'm gonna export it in my other terminal. And fingers crossed. Now let's look in the pods of the spacecraft's namespace. And we see both are running what we expected. Bummer that it didn't work before.
Keep that shelf for other demonstrations.
Yeah, that's the good one. So what we can now do, we only have our 2 initial pods, and we might want to see, has the state actually been restored, or is this just a fresh setup? Has the database lost its data, so to speak of? So we're gonna exec into the application pod again. We see our EOF error again, so that maybe is a good sign. We saw that one before. We solved it by running the command again. Now I'm running python manage py shell plus again. And we're gonna look at all components. And we see our stuff again, don't we? Ooh, I did not save that component, did I? Yeah, well, that just happened.
Yeah, okay, let's just imagine that
yeah. that of course is quite embarrassing, but of course we see the 2 different states in our 2 different shelves, one without the Ingress controller and one with the Ingress controller. And if I had actually saved the other component before, then yeah, we would have seen another title here in the component.
Okay, just pretend that this just worked. Move on. Yeah, thank you very much. I think we got a good glance at Getdeck and the SHA feature. And although it's not yet released, it's obviously a development state. I'm very happy to see this feature landing in one of the next Getdeck releases. I think this is also something that you want to talk about at the KCD, at the Kubernetes Community Days this year. But just because you said there's a Byteboot API and a desktop application, just with a few words, what is it and why do we need it, and is it possible to show us the Byteboot desktop? The Getdeck desktop. I'm sorry.
We're gonna find that one out. I just builded the latest release, and as I'm not quite involved in the development of that, I'm not quite sure if this is gonna work out or not. But we're just gonna try it. Can't be more embarrassing than this demonstration. And yeah, you're absolutely right. I'm gonna be talking about the shelf feature, of course, at the KCD, because this is really, really a great feature. And yeah, currently it hasn't been released to the public. I'm personally, I have worked with it in one of our projects. And of course, there are some kind of issues we're seeing here and there. The EOF that we witnessed, for example. Currently, we're finishing up on the testing aspect and some code cleanup, some refactorings, which hopefully should not be taking that much longer until we are able to release that. And yeah, as we've touched upon earlier, the Bible CTL is probably more suitable for people who have to maintain those clusters or maybe have to provide those clusters so that developers can work with that. And maybe developers also are comfortable working with that. Me personally, I usually prefer a good CLI over a graphical user interface. But of course, that's personal preference. And so with the desktop application, you will be able to have this graphical user interface where you can just click around, don't have to memorize all those commands and flags to those commands, but will be prompted. You're going to be having some drop downs with which you can work with. So basically to increase the convenience to developers to work with that without having to know or getting an in-depth knowledge of a CLI tool. And so I probably need a quick moment to see if I can set up and spin up the desktop application. Let me
And
check
just to sum this up, the desktop application is then talking to the API of Getdeck, and the API is basically doing what you did with BibleCTL, with an added layer of security and resource limitations. For example, we do have some a quota feature in the API that allows us to limit resources of users and groups, and to access, of course, just the cluster that I created or that belongs to my team. So this functionality is in the API. And the good thing is our developers do not need to have API access, Kubernetes API access to the host cluster itself. So since we are providing an API, which is based on REST, we can just control the Getdeck virtual cluster mechanisms in the cluster without providing actual access to the host cluster itself. Instead, developers only have an account with Getdeck, and with this account, they are allowed to manage clusters, create clusters and shelves, and restore from them, and connect to them, obviously, and all without having access to the underlying infrastructure, which should be considerably more secure than rolling out the BibleCTL.
I think I should now be up and running. I'm gonna share this window real quick. I hope this is the up-to-date version. Yeah, we're in there. Not 100% sure. Is this the latest version? Absolutely don't know if I have credentials for that, to be honest, or what my credentials are.
It's a bit odd, to be
Damn
honest.
it. Yeah, to me too. I don't think that is the most recent version, isn't it? But well, anyway, we don't want to do a deep dive in there. So basically what we can see here, you have, of course, a login interface, and you can access your clusters and other features. Yeah, but unfortunately, this doesn't seem to be the latest version which we're working here. So I'm not quite sure if it really is good to dive in there or to kind of try something in there, because honestly, I don't know if this currently works. Maybe we're gonna do that in another edition, or in a short edition when this is more mature. We can show some more features and compare it with the Bible CTL, and maybe give it some more time, the desktop application.
Yeah. Speaking about a short edition, we again missed our goal to stay within 30 minutes. Barely. But yeah, thank you very much. Let's call it a day. I hope that for the Kubernetes community days in Munich that we will get ready with everything that we want to show there and release everything beforehand. And if you do have any questions or any feedback, then please let us know in the comments below. And we do have a major rework of the Getdeck .dev website in the process right now, but you will find a lot of additional resources about this topic on our site, getdeck.dev, and of course on blueshoe.io and on our blog. Well, Robert, thank you very much and take care.
Yeah, you too. Have a good time.
Bye.
Bye.